Advanced Six Sigma Black Belt. Less than a third of the course left just by opening this. So let's get on with it. Oh, I'm going to say, I'm going to run this a little bit different. I'm assuming that if you made it to this part of the course, you're serious about it. You want to learn. So I'm not going to focus too much on the quizzes. What I'm going to do is in the discussions where I can attach spreadsheets, that's where we're going to learn the different tests and things like that. That's where the learning will be this time, in the discussion. Okay, let's talk about hypothesis testing. First thing is the null hypothesis. I know we talked about this before, but this is the hypothesis we will test. This is the H sub 0 is how I designate it. Null, just like it says, no difference, no difference. Some examples. Tomato plants will show no difference in growth rates when planted in two different types of soil. So the growth rate of one tomato is equal to the growth rate of another, even though they're in different soils. Another one is if we got a one-tailed test. Tomato plants do not exhibit a higher rate of growth when planted in a compost rather than soil. So I'm saying that the growth rate of the compost one is not greater than the growth rate of the one in soil. So those are two null hypotheses. We have what's called alternative hypothesis. In the case of the first one, the tomato plants show a difference in growth rates when planted in two types of soil. In other words, the growth rate of one is not equal to the growth rate of two. The other one, tomato plants exhibit a higher rate of growth when planted in compost rather than soil. In other words, the growth rate of one in the compost is greater than the growth rate of the one in soil. That's the alternative hypothesis. We can't both be happy with the null and with the alternative. We have to choose one or the other. So we have two choices for the null hypothesis. First thing we can do, we run our test statistic and we reject the null. We just say, nope, it's not true. Or we can fail to reject the null. We notice I'm not saying accept again. I'm saying fail to reject, because anytime we do these tests, there's always a probability, a small chance, or some kind of chance that we get it wrong, right? So if we reject the null, then we have to accept the alternative hypothesis, which says that there is a difference. Okay, remember this thing. This is the alpha and beta errors, right? And this is the degree of risk that we can draw the wrong inference from our test statistic. Okay, so what we do is every time we do a calculate, right? I'm going to use the example norm dis. We punch those numbers in, our point of interest, our standard deviation, our mean, our standard deviation, cumulative or whatever, and we get a number. That's known as a p-value. So if I get, let's say, just for an example, it comes back 0.12456, that tells me that there's probably about a 12% chance that I'm going to make an error when I make this call, right? And our alpha error, is that too much or is it acceptable? Usually you want 5% or less in industry. Sometimes you want 1% or less. Again, we calculate that risk. That's our p-value. So when do we reject the null hypothesis? There's an old saying in this testing: if p is low, HO must go. We would reject the null hypothesis. If we reject the null hypothesis, we accept the alternative hypothesis. For example, if I use norm.dis and plug in the value, 2.3 is my point of interest, 4.2 has been my mean with a standard deviation of 0.8. I do want to be cumulative true. I punch all that in, I get a p-value of 0.008774, or 0.8774%. Chance that this is probably just random variation I'm looking at. That's a low p-value. So therefore we would reject the null hypothesis and accept the alternative hypothesis. In this case, 2.3 is statistically significant when compared to the average and standard deviation. We reject the null and accept the alternative because the p-value is low. These are the tests. This should look familiar. You should see this in the reading. You should be able to download it. If you can, let me know and I'll post it too. I'm not going to go over these. What I'm going to do is in the discussion, I'm going to just put out some spreadsheets. I'll work an example and then I'll give you some other problems to work with. Okay, that's the best way to learn. But these are our tests. These are the 8 tests we're going to do.